Welcome to the Gravity Engine Spaceship demo walkthrough. We've opened the Spaceship demo scene from the demos folder that come with the asset. To just show you what's going on in the scene, we have two planets orbiting a star. We've created a spaceship and given it an initial orbit. And we've added a grid and some controls to allow you to change the orientation of the camera, which is a very useful way to see the paths that the ellipses are taking. And we have also added some interactivity to control the rotation of the spaceship, and then if you press spacebar you can change the orbit. So if we change the orbit at the closest point by applying a little bit of thrust, tapping the spacebar, we can actually change the orbit of the spaceship. We rotate it again. If we thrust at the minimum point, we lengthen the orbit. This obviously isn't a game unto itself, but it has a lot of the core elements that you would need to create a gravity-based game. So let's look at some of these elements piece by piece. By this point, the star and the two planets and their orbits are things we've talked about in the Gravity Engine tutorials. So the new things here are the spaceship, the grid, and the movable camera. The grid is probably the simplest of these. It shows you the grid both in the scene view and in the game view. It's a fairly straightforward script that creates the points in the grid, and on start draws those points, and also has these if Unity editor clauses so that it's drawn in the inspector, in the scene view when you're editing the game, so you can understand where the grid is. The value of the grid is it gives you a visual reference plane. One of the things with orbits is that an orbit inclined at some angle is just an ellipse of a different shape, and it can be a bit of a challenge for your eye to understand whether it's an orbit in the plane or actually an orbit coming towards you. And so adding the grid gives you a little bit of a reference point for that. The camera rotation is similarly fairly simple. What's done here is we've put the camera underneath another object called camera boom, and on the camera boom we've attached a spin script. And what that does is the camera is 30 units away from the origin of the camera boom, pointed at the origin of the camera boom. And by rotating the camera boom, you essentially have a scene view where your camera is always pointed at the star and you can spin it around the star. And if you look at this camera spin script, it's very straightforward. We're really just getting a key code in the update method here and then performing a rotation using angle axis and picking either the vector right, which is the x vector 1, 0, 0, or the vector forward, which is the z vector. And the spin rate is set by a public variable that you can control in the inspector. The most interesting aspect is the spaceship, and we've created a script called Spaceship, which does two things. It provides rotational control using the arrow keys for the orientation of the spaceship, and it provides thrust control using the space key, and then changes the velocity of the object in the scene by calling into the gravity engine and having thrust applied. So let's look at that script. So if we look in the update method, in the case where the spacebar is pressed, the key new item is here, where we get the singleton reference to the gravity engine and do an apply impulse to the end body, which is something we grabbed from our parent in the start method. and we apply an amount of thrust, and that thrust is determined by the three-dimensional vector of the axis, which we have modified by the thrust magnitude and rotated to align with the rotation of this object. Using the arrow keys is done much in the same way that we rotated the camera boom. We again just get a key and apply quaternion angle axis. So here you have the core elements for a space game. You could, for example, make the objective to rendezvous with one of the planets and match your orbit to the planet's orbit by applying thrust in the right directions, including trying to align with the planet that's in the inclined orbit and moving out of the direction of the grid. And that turns out to be a pretty interesting challenge. Hope you find this demonstration program useful. Thanks for watching.